Good afternoon, dear students. Today's topic is dental materials and their properties. It's a very important topic for the dental specialists. So we are talking today about the different biophysical properties of the material and why that properties are important in our life. So let me look on the basic dental materials. As you can see here we have three main types. There are ceramics that divides to inorganic salts, crystalline ceramics, and glasses. Metals can be divided to alloys and intermetallic compounds that is used to the special brackets, etc. And polymers, we have three groups of the polymers: rigid polymers, boxes, and elastomers. So let's start from the thinking about the ideal material. As you know, nothing ideal exists in our life, but we try to receive some ideal material for the treatment of the entire tooth, and we think that ideal filling material must have four categories of the properties: physical properties, biocompatibility, aesthetic, and application properties. Let me look on that properties. What does it mean, physical properties? It means that material that we'll use must have same characteristics with the natural teeth. For example, low thermal conductivity, same thermal expansion, same resistance to the force, etc., etc. Biocompatibility. Everybody hear that word, and it means that material can coexist together with tooth and body in the biological equilibrium. So no harmness to our body, and in our oral cavity we have a high level of solution. In our oral cavity we have some enzymes, so no chemical reaction, no interaction with that environment. Next type is aesthetic. As usual, people want to have same color of the plumb with the teeth, with same structure, same texture, without with no problem for their beauty. And last but not least is application. You want to work with the good material, with predictable properties and controllable chemical reaction. You want to have easy manipulation and have ability to to work with that without the problem. So application is very important, especially for the specialists. Let me look to the table. Here is comparison between the different type of the materials. Here is, for example, we can look on the metals, ceramic, and polymers. We can see that hardness big for that type, but polymers are soft, but density same, low density. But in the case of thermal expansion, it's an important thing. We have low thermal expansion for metals and ceramic, but high for the polymers. And thermal conductivity is very, very high for the metals. So we need to know that table to think about the usage of the different types of the material for the different purpose. Let me start from the mechanical properties. Here is first one is stress. Stress is the force that applied to the some area, and we have that formula that sigma is force divided by area, and unit for sigma, let me look on that, is Newton per meter square, and I think you remember it is Pascal. So same unit with the pressure. And we can see different type of the stresses, basic types for the dental structure. It is compression stresses when we have the increasing of the cross-section area, tension stresses when we have the decreases of the cross-section area, and shear stresses when we have the total changing of the shape of the tooth. And let me look on the examples of that stresses. Here is, we have different pictures of the different types of the stresses. Here is, we have tensile stresses between the tooth, upper teeth, and here is amalgam restoration, and in that part we have tensile stress. Here is again interaction between two tooth, here is, and we have again tensile stress, and that part we have applying force, and here is, we have that stress in that area. In the case of the denture collapse, we have applying force on the ends of that collapse, and because of that, in that part, we have again tensile stress. And in the case of the breach, here is big breach on that is fixed on that tooth, we have that compressive and tensile stresses together, compressive and tensile stresses. What then important also important the strain. We have two parts of strain, two types of strain, absolute delta L and relation strain is epsilon. As usual, we are talking about that type of strain. It does not have the unit, and here is ratio between the absolute value and initial value of something. Here is centimeter per centimeter, and we receive the percent. And between the two values, we have the connection, we have the relationship, and we can see it here. That formula give us that relationship. Stress by strain is E. E is called elasticity or Young's modulus. It can be found in the table. It is characteristic of material, and it gives us information about the elastic properties of our materials. we can draw the diagram that connect together, that give us function dependence between the strain and stress. Let me look firstly on the stress. If we increase stress, increase the applying force, we receive first of all direct relationship. Here is elastic deformation, and in that case, when we work in that area, if force stop to be applied, our body return to its initial size. After that, we receive that part. Here is plastic deformation. In that case, in that plastic deformation, we cannot return material, cannot return something to the initial size, to the initial shape, and we receive some constant deformation. And we can characterize that special stresses with the special limits. Here is, in that point, we receive elastic limit. So sigma elastic. Next two points, B and C, yield stress at start of the plastic deformation, and here is the maximum value of our stress that can be applied to the body, to the material, and here is ultimate stress, maximum value, ultimate stress. And after that, we receive the breaking of the material. In the point E, we have breaking, and that value is a breaking stress. Breaking stress. If we compare different materials, we can see that materials have different plastic behavior, and we can divide it to the several types: ductile materials and brittle materials. Without plastic behavior, materials are brittle, and with a big amount of plastic behavior are ductile. And total strain at a fracture, in the point of fracture, elastic strain and plastic strain together is called the elongation. And for metal, that parameter is important for the work in dentistry. And we can also measure from that graph, we can measure different things that characterize the energy. So all energy that requires to fracture the material, here is that area, that total area under the curve. Here is, I crossed it. It is tonus, energy that required to destroy the material. And that part here is triangle. It is elastic energy, have the name resilience. So here is energy that exists only in the elastic part of the deformation. And we can compare it, and for the plastic deformation, as usual, you must apply more energy. Sometimes material can work with a big force, short time applied big force, but after a long time, 1,000 cycle of applying of the small force, that material can be broken, sorry. So that has special name of that situation. It is fatigue. So we can be we can feel fatigue and material too. And because it is important for the oral cavity, we chew every day, and every day we apply some small forces. Our natural tool can work, but our material must be examined to that thing. And you can see here is the picture of the comparison of the different measurement for the glass in dry environment, in wet environment with the temperature 22, and in wet environment with the temperature 37. And you can see when temperature increase and when environment change, we have the less ability to force out the maximum stress. So here is, we have decreasing of the maximum stress in the case of the increasing of the cycles of the failure. How can we measure something? We just talked about the fatigue. We do some examination, we do some experiment, and also for the measurement of hardness. We have special device like that, and we compare the hardness of different materials with help of the experiment. We put the material in that place, and that material set here, and we forced into that material indenter. Indenter, it is some metal with special shape. For the different type of the examination, we have different indenter. Here is Brinell indentation. We receive the cycle shape of that dent. Next is, let I show you. Next is Wickel. Wicker's hardness. Here is, we have indenter, diamond shape, square diamond shape, and we receive that indentation impression with that square shape. And here is relationship between the Vickers hardness number and Brinell hardness number. And loop hardness has the same indenter, and Rockwell. In the case of Rockwell, we have some cones. Here is, if you can see, that list of the different materials, different things with the different hardness number. Here is dental porcelain. It has maximum in that list. Here is natural enamel, and dentine, of course, has the lowest hardness number. Important property is viscous flow, because you will work with the different fluids that have viscous and viscoelastic properties. You remember from the lab work, you did lab work about the viscosity, that some liquids has the viscosity that does not change. They have name Newtonian fluids, and for example, water and oil are Newtonian fluids, but all suspension are non-Newtonian fluids. So if you are talking about the materials, impression materials, we have some suspension, and they are non-Newtonian fluids. They have special viscoelastic properties. For example, we can talk about the plastic fluids. They don't flow until we press it, until we apply the force. Pseudoplastic fluids, like some fluoride gels, they decrease viscosity when increasing shear rate. Next one, dilatant fluids, opposite way, increase viscosity when we increase the force. And last one, thixotropic fluids, another fluoride gel, they decrease the viscosity, flow more freely when we shake it, vibrate it, etc. So in the prescribing of some materials, prescribing for work with that materials, you can read what you need to do, how do you need to work with that. So for example, if you want to do receive some shape of the teeth, different tooth here, you need to put the putty here, apply it not more than 20 seconds, and after that remove it very, very quickly, because that is dilatant fluids, and when you move very quickly, more pressure apply, they will increase viscosity and you receive a very good shape of the tooth. And as usual, you will work with a powder, you will mix it with water, and you receive some suspension and work with that. Here is example of the impression of the tooth. Here is next properties are thermal properties. As you know, I think you tried that, you can eat ice cream, and after that, 10 minutes after, you can drink coffee. Difference of temperature between that ice cream and coffee is near the 100 degrees Celsius, and it's a big difference. And as usual, you don't feel any pain in that case, because yours enamel and dentine protect your nerves inside the tooth and from that influence. We must remember about that and use similar materials that will protect too. So we are talking about thermal conductivity and thermal diffusivity. Thermal conductivity, it is speed of the propagation. Give us information about the speed of the propagation, how many watts propagate through the between the body with temperature T2 and temperature T1 at the distance d. So how quickly. And next is the most important, it is thermal diffusivity. H, it connects together thermal conductivity, heat capacity, and density of the material. And thermal diffusivity give us information not only about the speed of propagation, but about the speed of increasing of the temperature. So how quickly interior surface will heat up when exterior surface is heated. And thermal diffusivity, if we look here in that picture, for dentine is very good. It is insulating material. But if you compare with the pure gold very conductive. And if you set the bridge, gold bridge, under gold bridge we need to set some cement to protect our tooth from the propagation of the heat. Also, let I return here, it is very important to remember about the thermal expansion. It means the increasing of the volume of the plumb and tooth, and our materials, restoration materials, must have similar value of the expansion, because if plumb will have higher expansion than tooth, we receive destruction, we receive breaking of the tooth. That is not good. But if we use plumb with a less expansion, we can lose that plumb. It will be removed from the tooth by a natural manner. Next important thing, it is electrical properties. Because you remember about the electrochemical series, list of elements according to their tendency gain or lose electron in solution. And we have that list, and we can see that metals with a large positive electrode potential, here is platinum and gold, they are resistant to the oxidation and corrosion in the oral cavity. They are very good for the bridges, etc. And if someone has some metal in the oral cavity, for example, that was made from the gold, next bridge cannot be made from the ferrum, from the iron, because in that case, if we use iron, here is, you can see, for iron, minus 0.4, here is plus 1.6, and we receive the electrolytic pair, and we receive current, and patient will feel some unusual sense and some discomfort. And electrical resistivity also important. You remember that electrical resistivity is rho For different materials, they are different, and in the case of human enamel and dentine, they are insulator, but if you use some metal thing, and they will generate voltage. So we must use insulating cements to reduce that problem. And biocompatibility is very, very important because they combine, that property combine together patient problem, material problem, and material function problem. They must be inert to the surrounding tissue. For example, a shift for the artificial tooth must be made from the inert metal, like the titanium. And before the usage in the real clinics, first of all, we do the in vitro tests. After that, animal experiments. And only after that, when we shown that everything okay, we can go to the clinical tests. And after the clinical tests, firm start to produce that materials and to sell it. We have different chemical and physical factors in our oral cavity, mechanical factors, applying of stress, and that factors also must be tested in the case, especially in the case of animal experiments. Okay, it's all today. So I hope that lecture was helpful for you, was useful, and I wish you a good day. Bye.